Before it becomes a minty paste, the primary abrasive starts here. Calcium extracted from organic cattle bones. These bones are a byproduct of the food industry, repurposed to provide the gentle grit that cleans our enamel. To extract the calcium phosphate, we must first break the structural integrity of the material.
Any residual organic fats must be boiled away. Impurities here would ruin the flavor and texture of the final toothpaste.
Steam at 120 degrees sanitizes the material, stripping away the last of the organic tissue. How clean, the bones enter the calcination phase, to be transformed into pure mineral ash.
Intense heat performs alchemy, leaving behind only the inorganic skeleton, pure hydroxyapatite crystals.
The result is a sterile, porous mineral, rich in calcium and devoid of any biological matter. The mill pulverizes the calcined bone into a microscopic powder, fine enough to polish teeth without scratching them.
Only particles smaller than 20 microns are accepted. Anything larger would feel gritty in your mouth.
We have created our base abrasive. This white flour is the backbone of the paste we are about to make.
The powder must be round and soft. Sharp edges would damage the gums. We need gentle polishing power.
This facility produces 50 tons of calcium abrasive every day, shipping it directly to the mixing plant. The raw extraction is complete. The bones have vanished, replaced by a pristine industrial ingredient. Now, the powder travels to the main facility, where it will meet the mint, the fluoride, and the water. The journey takes the refined powder from the bone processing plant to the high-tech hygiene facility.
Security is tight. Every ingredient entering this facility must be tracked, verified, and certified pure.
The powder is logged into inventory. But a dry powder cannot clean teeth alone. It needs a liquid vehicle.
The thick, syrup-like liquid is pumped into holding tanks, ready to be deployed on demand.
The flavor vault. Here, millions of dollars worth of concentrated mint oil are stored under strict temperature controls.
This concentrated oil is so potent that a single drop could burn your tongue, yet it provides the refreshing blast we crave.
The active ingredient, fluoride, is handled with extreme caution. In small doses, it strengthens enamel. In bulk, it is hazardous. To create the satisfying foam we expect, we add sodium lauryl sulfate, a powerful surfactant derived from palm or coconut oil.
The ingredients are assembled. The team is ready. The chemistry set is complete.
We leave the warehouse environment. From this point on, hygiene is absolute. No dust, no dirt, no contaminants.
Welcome to the mixing deck. Here, the bones, the mint, and the chemicals will be fused into a single, cohesive paste.
This vertical fortress is the heart of production. Gravity is our tool here, allowing ingredients to flow downward from storage to the mixer.
This is the brain of the factory. The master operator selects the specific formula for today's run. Automation handles the liquids, but the solids, the powders and gums, must be weighed with pharmaceutical precision.
This is xanthan gum, a thickener. Too little and the paste is runny, too much and it won't squeeze out of the tube.
Our bone calcium is added next. It is dense and heavy, requiring a separate weighing hopper.
The system is foolproof. If the wrong ingredient is scanned, the mixer will lock down and refuse to start.
Any clumps or foreign objects are caught here. Only the silky, smooth powder is allowed to pass to the mixer. Rare earth magnets guard the line, capturing any microscopic metal shavings that might have come from the machinery.
The water used is not from the tap. It is purified, deionized, and UV blasted to ensure it is chemically neutral. The valves open. The liquid carrier fluids are the first to enter the vessel, creating the bath for the powders.
The ingredients are staged. The stage is set. Now, the violence of creation begins.
The vessel fills with the liquid carrier. It is the swimming pool in which the solids will soon dissolve. The anchor agitator begins its slow dance, ensuring no material is left clinging to the cold steel walls.
We add the thickeners first. Without them, the toothpaste would just be chalky water.
The high shear blade acts like a blender on steroids, exploding the gum particles to hydrate them instantly.
Now, the star ingredient arrives. Ton of crushed bone powder crash into the mix. The viscosity spikes. The motor draws massive current to force the dry calcium to accept the liquid. The detergent is added. But there is a problem. The mixing has trapped millions of air bubbles inside the paste. Air is the enemy. It creates voids in the tube and leads to spoilage. We must suffocate the mixture. We apply a hard vacuum. The drop in pressure forces the trapped air to expand and rip its way out of the paste. Teflon scrapers ensure that not a single gram of paste escapes the mixing action. Uniformity is key.
The friction of moving this heavy mud generates enough heat to cook the ingredients. We must chill the tank actively.
Finally, the flavor, added last to prevent the volatile oils from evaporating under the vacuum. The reaction is complete. The bone dust, the water, and the oil have become a single substance, toothpaste. The batch is finished. 5 tons of fresh paste are ready to leave the mixer and begin the journey to the tube. The paste is too thick for standard water pumps. We use heavy-duty lobe pumps to push the dense mud without separating the ingredients.
The mixture travels through an arterial network of stainless steel, heading for the maturation sector. The paste is not ready yet. It needs to rest. We pump it into these holding silos for a critical process called aging. The violent mixing broke down the gel structure. It needs 24 hours to recover its viscosity and set into a stable paste.
Before we fill a single tube, the lab must confirm that the bone powder is evenly suspended and the chemistry is safe.
We test viscosity. If it's too thin, it runs off your toothbrush. If it's too thick, it won't squeeze out of the tube.
We confirm the density. If there are still air bubbles, the tube will be underfilled, and the customer will feel cheated.
The organic bone origin makes this step vital. We must ensure absolutely zero bacterial growth before releasing the batch.
A final safety net. A mesh screen catches any dried particles that might have formed on the tank walls during aging. Toothpaste is expensive to waste. We use a rubber projectile called a pig to squeegee the pipes clean between batches. The hopper acts as a buffer, holding just enough paste to keep the hungry machine fed without overflowing.
The tubes arrive pre-printed and capped, but they are open at the bottom. This is where we will fill them, from the rear.
The tubes meet their outer shell. The cartoner runs at 300 units per minute, a blur of synchronized motion. Vacuum cups erect the carton instantly. If a box fails to open, a sensor detects it and stops the pusher arm to prevent a jam.
This code matches the one crimped on the tube. It is the forensic link back to the specific batch of calcium used.
A missing instruction leaflet or an empty box is detected instantly. The checkweigher kicks any underweight unit into the reject bin.
The accumulation table buys time. If the next machine jams, the cartoner can keep running, filling this buffer zone. Inside the tunnel, heat shrinks the film by 40%, locking the 6 boxes into a solid, stable brick.
The final layer of protection. A corrugated shipping case is erected to hold 12 bundles, 72 tubes in total. The Delta robot moves faster than the human eye can track, packing the case with geometric efficiency.
No glue here. Pressure-sensitive tape seals the master carton, ready for the rigors of the supply chain. The product is now fully dressed, from a raw bone in a yard to a sealed case of 72 tubes, ready for the world.
To save floor space, the finished cases take the high road, traveling overhead to the palletizing hall.
Welcome to the robot garden. Here, heavy lifting is obsolete. These arms never tire and never hurt their backs. One pallet holds over 4,000 tubes. That's enough toothpaste for a small town to brush for a month. We wrap it tight. The plastic tension unit applies 30 pounds of force, turning the loose boxes into a single solid brick. The license plate. This barcode tells the warehouse system exactly where to store this 1-ton load.
Not everything leaves. We keep 12 tubes from every batch in the retention library for 3 years.
We torture test the retention samples. High heat and humidity ensure the paste won't separate if the truck sits in the summer sun.
The 5-day microtest is clear. The bacteria count is 0. The batch is officially safe for the public.
With a single keystroke, the inventory system unlocks the pallets. They are no longer waiting. They are active stock. No humans needed. The AGV robots receive the release signal and immediately begin moving the stock to the loading bays.
Batch 409 is now stored in slot Z45 Alpha. It will sit here for less than 24 hours before shipping out.
We pump it with air until it fails. The tube must withstand 50 pounds of pressure, far more than a human squeeze, before bursting.
The paste won't be thixotropic, solid when sitting, but liquid when squeezed. If it's too stiff, the tube will split.
We simulate 3 months of brushing in 1 hour. We need to confirm that our bone powder cleans without sanding away the enamel.
This is the RDA score, relative dentin abrasivity. The calcium particle size must be perfect to polish, not scratch.
Fluoride is the cavity fighter. We verify the concentration is exactly 1450 parts per million.
We simulate years of gravity in minutes. If the liquid separates from the solid, the user would squeeze out watery sludge.
The binder held. The bone powder remains suspended in the glycerin matrix, even under extreme G-force.
Since the abrasive is natural bone, we must prove there are no heavy metals leached from the animal's environment.
The packaging must survive sweaty hands and bathroom humidity, without the ink smearing or fading. We shake it until it rattles. If the tubes rub against the carton and wear off the paint, the product looks old before it's sold. The pH must be neutral. If it's too acidic, it hurts sensitive teeth. If it's too alkaline, it tastes like soap.
The torture is over. The science is sound. The batch is certified safe for human use and released for dispatch.
The sun rises on dispatch day. The orders have come in from retailers across the country.
Truck packing is a game of Tetris. We must maximize the volume without exceeding the axle weight limits of the highway.
26 pallets will fit in this trailer. That is over 100,000 tubes of toothpaste in a single shipment.
Dunnage bags fill the voids. They prevent the heavy pallets from shifting and crushing each other during a sudden stop.
The cargo is sealed. The number on this bolt must match the paperwork at the destination, or the receiver will reject the entire load.
The factory's job is done. The baton is passed to the logistics network.
At the distribution hub, the bulk pallets are broken down. Our toothpaste is mixed onto pallets with shampoo, soap, and towels.
Finally, the destination. Under the bright fluorescent lights, it waits for a customer.
The consumer sees a simple hygiene product. They don't see the bones, the furnaces, or the chemistry that made it possible.
The journey ends here. The calcium that once supported a cow now protects a human smile.
From the raw, organic waste of the stockyards, through the purifying fires of the kiln,
to the precision chemistry of the mixing deck.
And this is how modern factories produce toothpaste, from animal bones to the finished tube.